Okay, so video 6 now on NMT, and it's at this point where we can start to see that neural machine translation improved over statistical machine translation. And it really started around 2015 with the IWSLT machine translation task. Teams like mine, we participate in these tasks where the data is provided by the shared task organizers. We build a system, we translate some evaluation data, we pass that back to the task organizers, who then compute some sort of ranking of the various machine translation groups. So sometimes we win these, sometimes we lose, but these are the sorts of tasks that we are well used to participating in. So in 2015, up until that point, SMT had won out on all of the tasks for all language pairs. But at this one, an NMT system produced by guys in Stanford University was put up against a range of different SMT systems: tree-based, syntax-based, and phrase-based. So there were two sets of evaluations done here. One on evaluating the raw output, but also a post-editing task here. So you can see English-German, firstly. It's not an easy language pair. And based on TED Talks, you'd be well used to seeing TED Talks, I'm sure. And two metrics essentially being used: TER, which gives us an analysis of the overall quality, as you will know, and HGR, human in the loop, which gives us an analysis of the post-editability of the output translations of the various system types. And a group in FBK in Trento in Italy did a thorough evaluation of the performance of these four systems. And essentially, they found out that overall, the quality of the NMT system was better. You can see here, because TER is an error score lower, indicates higher quality. So NMT is better than all of the three sort of state-of-the-art at the time SMT systems. In terms of lexical errors, there were fewer. So it picked the right words, the most appropriate words, more often. Morphological errors were fewer. So again, when we're translating into German, from English, there are lots of different morphological variations that we need to take into account. German is a morphologically rich language, and again, both at the word level and at the lemma level, the NMT system won out again over the three SMT system types. In terms of reordering, so again, NMT required less word ordering. So a shift is essentially just a cut and paste. You might highlight 2 or 3 words. So the translation is correct, but the words have appeared in the wrong target language order. So the number of shifts that were required in the editing process was considerably fewer from the NMT system. So that indicates that it produced, in general, better word order than the 3 SMT systems, as you can see. And summarizing, they found that the NMT system sort of degraded more quickly with longer sentences, but computed fewer linguistic errors in terms of both word selection, morphological errors, and word order. And they even did a more thorough investigation into the different types of word order errors, and they found, for example, so you'll know that in German, typically, in a basic sentence, the word order is very similar to English, but in a more complicated clausal structure, the verb goes to the end. So this is quite a difficult problem for SMT, especially if we only take in-ground language models into consideration, because typically the place at the end of the sentence, which is where the target language main verb ought to be placed, is too far away, given the target language model that we're dealing with. So SMT gets these things wrong, and you can see here that there were 70% fewer types of verb reordering required for NMT. So it was at this, as a result of this shared task and this kind of seminal human evaluation of the side-by-side performance of SMT versus NMT, that the rest of the field started to sort of prick up their ears and think, actually, there's something in this. I better switch over rapidly to NMT, because even though it's the new kid on the block, it has a huge potential here, even on a difficult language pair, on a difficult a difficult area of translation, namely TED Talks. So from this point on, more and more people started to investigate neural machine translation, and it very rapidly became the state of the art as we see today.